Welcome to another episode of Ember Weekend. I am Jonathan Jackson from the future, and this is going to be the conclusion of the interview with Chris Thoburn. We're going to talk about some cool stuff, including smoke and mirrors and Igniter and some other stuff. So if you recognize some familiarity with the intro and outro, it's because it's from last week. But the main bulk of the interview is new stuff. So please enjoy.
You are listening to Ember Weekend. We're here today with Chris Thoburn.
Hello.
That's a very timid hello. I feel like well, now I'm talking to like a foam sheet. We have like a separation here.
Well, mostly I was just confused. I don't think I've heard my real name in so long. Everyone just says, "Here's Runspired."
Here, so. Oh yeah, that's true. So here's Runspired. Right, correction. Yeah, we'll have a correction corner later. But anyways, welcome to another episode of Ember Weekend. I'm Jonathan Jackson.
And I'm Chase McCarthy.
And we are here with Chris. We're going to talk about some really cool stuff. So let's just dive right in. Cool. So, okay. So we definitely know that you're doing a lot of Ember Data. But last time we were talking, we talked about Smoke and Mirrors, which is your side project. And I know you want to talk about that. I suspect there's some other things, but maybe we start there?
Yeah, let's start there. So Smoke and Mirrors is a gift that keeps on giving. I mean that because every time I dive deeper into improving its performance and improving its APIs, I learn new things about JavaScript. I learn new techniques. I learn more about optimization and profiling. And it really just, if you want to learn everything you need to learn about performance work in a browser, try to build a universal long list solution. You will very quickly learn it. Or maybe not. I guess this has been a 3-year journey for me. So you will slowly but quickly learn it. I've been promising 1.0 on Smoke and Mirrors, I feel, for like at least a year, maybe longer. And that's a story that's been delayed for a few different reasons. Part of it was I realized I needed a better scheduling setup. And initially I took a stab at that with Ember Runraf, which caused Backburner Ember's run loop to flush with request animation frame. I bumped into some timing issues with that still, where I wasn't as guaranteed of the order of operations as I had assumed I was. But more importantly, I really wanted a solution that was built into Ember, that was really like embraced by Ember, that handled these concerns of how do I make sure that I update my UI and time measurements and maybe do an additional update within a single frame or a single paint, and do that on a framework level. And so this project was born. It's called Igniter. I've talked about it a little bit in the past at some conferences. I'm sure there will be a video at some point. But something about that library that I haven't really talked about, think is just going to revolutionize Ember, is this concept of cancellation tokens. And I'm a little bit sad because we just had TC39 this last week, and cancelable promises, which are an implementation with cancellation tokens in them, advanced as a spec, and I just don't feel like it's advancing as a spec in the correct way. But that's a debate for another day and a different podcast. I won't bore you with what I think is wrong with them, but I will tell you what's awesome about cancellation tokens. And specifically, what's awesome about them in the way that if and more likely when Igniter lands, you'll be encouraged to use them. Instead of having a global object Ember run, you would have a scheduler service. And the scheduler service is for scheduling any work that has the same lifecycle as your entire application. And then you'll have in your routes a schedule hook. And that's for scheduling any work that has the same lifecycle, the lifespan as that route. And then within a component, you'll have a schedule hook. And that's for scheduling any work that has the same lifecycle or lifespan as that component. And what's magical about this is that we give your app a token, and every route also gets a token, and that token inherits from that parent app token. And then every component gets a token, and it inherits either from its parent component, or if it's a route level component, from its routes token. And the thing about cancellation tokens is you could sort of look at them like a tree or a DOM tree. And at any point, if you cancel a node, all the nodes from that point down are canceled. You can cancel an individual node, or you can cancel a whole like subtree. So something that's really annoying in Ember is async cleanup. If you schedule anything into backburner, you have to remember to tear it down. If you're doing anything async, you have to remember to check for is destroyed or is destroying in the callback. If you're doing anything in tests, you've bumped into auto run issues. You bump into situations where you maybe like scheduled some network requests or find requests on a route, but then you left that route, you're not even on that route anymore. So lots of async cleanup issues. Well, if you have these cancellation tokens and they're tied to the appropriate lifecycle, when you call schedule, you're going to get back a token. And that token, its parent, is going to be the thing that you called schedule from. So when you call schedule from a route, if that route is canceled, then all the things that you scheduled through that route are canceled with it. And that includes anything that was scheduled through components in that route, because they've all inherited from further up the tree. This allows you to just take entire portions of your app and just say, nope, you're done. Nope, you're done. Or even in your test suite, when you tear down an app instance and set up a new app instance, nope, you're done. So you stop leaking state between tests so much. You have a much better story for, I want to stop navigating to that route and I want to go navigate to this other route instead. You have a lot less work to do in bookkeeping. And best of all, you don't actually have to see that any of this happened. All you know is that you called schedule in the correct location. So I think that is going to be pretty cool. I think that this is, it's an API that is going to have to go through several revisions. It'll be several RFCs, maybe just one, but probably several RFCs. Rob Jackson began the work of kind of exploring what this work looks like with a kind of like a automatic cancellation of run later sort of hook on routes, I believe, recently. So there's some very, very interesting ergonomic wins there that I think that we can achieve that would really put us on solid ground as an application framework.
Yeah, that sounds great. I mean, it seems like it solves like a portion of the problems that something like Ember CLI concurrency, or is it Ember concurrency? Ember concurrency. Yeah, Ember concurrency, and then what's the other one?
It's
the newest concurrency library, the one that by Robert Jackson, Ember something. Why can none of us think of this?
So Rob Jackson's thing is actually specifically to be in line with this idea.
Okay. Yeah, it sounded like it.
Yeah, this is why it sounds similar.
Right. Okay. Because the Ember concurrency it solves that problem and also others. Also gives you ways to do like throttling and debouncing.
So this is the other great thing about cancellation tokens. If we get the spec right, is that they interop between lots of different async primitives, which means that Ember concurrency can piggyback off these same tokens. Promises, cancelable promises, all sorts of things. Animation libraries cancel off there's piggyback off these same tokens. So if we've all got this token idea, what we gain back is an ability we lost when we moved to single page applications. In the web a few years ago, if you went into cleanup state, you didn't have to, because you could rely on the next page, just the act of navigating to the next page, or the act of refreshing, or the act of navigating back, to cancel all this pending work. We don't get that with single page applications anymore. But if we have cancellation tokens and they flow through our entire document, then we get that again. So we get a lot of the wins that we gave up, and we get a lot of the ergonomics that we gave up back.
So I'm thinking if you were going to solve, say, a problem with like an autocomplete, and as you're typing, it's trying to autocomplete, but every time you type a new character, it has to cancel the last one. Do you just end up with the token of the cancel, and every time a new character is typed, you just give that token and say, cancel this one? Do you have an API for that?
I don't even know. That's something that's the domain of something like Ember concurrency.
Okay.
That's not the domain of something like a token. The token is just a primitive for, is this thing canceled or not? And if it's canceled, don't do it.
Okay. So, but there's no, but the cancelable promises or the token, what were you calling this?
The cancellation tokens?
Yeah, cancellation tokens. Those literally are like, I have a key, and at any point I can take this key and I can hand it to you, and you can cancel anything that's reliant on this. So I can use that API for whatever, but
Yep.
the autocomplete is where.
So
that would be.
internally, Ember concurrency will likely use
Yes.
cancelable
Yeah.
tokens.
Okay, that makes
Yeah.
sense.
So it's not an async primitive itself. It's a primitive that other async primitives can use to have interoperable cancellation.
Is Ember Lifeline?
Yeah,
Ember Lifeline.
right.
That's the one that I was
You
thinking.
know, if only we had like a lifeline that we could have used
Yeah,
to
I
ask
mean,
the
one,
audience.
one lifeline, just like, hey,
Yeah.
someone has to know this. I'm gonna call Rob Jackson.
Yeah. So Igniter. That's the project that I'm hoping will bring that. And I think I'm going to have a good bit of time to work on it again soon. It's another one of these libraries that I think I've promised for a long time. But this one, unlike Smoke and Mirrors, this one has been a different research project. Smoke and Mirrors has been a growing project where learning about how to best utilize the platform has been the big challenge. With Igniter, the challenge has been learning about the platform itself. Before I proposed the first version of Igniter, I had to learn a ton about these things called microtasks. And then I had to learn a whole bunch about request animation frame and how it was actually implemented to prove that microtasks and request animation frame and all these other things interop with each other in predictable ways. And so there was just a lot of like browser level research of learning, of spelunking, of playing around, demonstrating that things could work and how they would work that had to be done. But the end result of that, I think, is a very robust vision for how to build a really solid task scheduler for the Ember community.
And it seems like it's got a whole different level of concern in that you have to also plan for the future. You have to be able to predict what is the standard moving toward, because you kind of want to follow along with that.
So back to Smoke and Mirrors. 1.0 is coming. Still.
Heard that one before.
Yeah. It's closer than you think. It actually runs now. It has way more bugs than I can allow to be shipped to any application, even the simplest application. But it actually runs now. In terms of performance, I was hopeful that it would be about 100 to 1,000 times faster than the last miner that I put out. And I know that's a really big jump. Is it going to be that fast? Answer is, I think it'll be about 100 times faster. How did I get that fast? Now, that's an interesting story. So if you know anything about the implementation of Smoke and Mirrors in 0.5, 0.6 lifecycle, you essentially have a component that has a custom each that renders additional components. And then those components control whether or not their content is rendered. In 1.0, you only have one component. So there's a massive reduction in scopes. And not only do you just have one component, but that one component is now using an algorithm that makes roughly 7 passes less across the data from the moment that an array is received to the point that it's able to put it out on screen. So most of the gains come from those two things. There's this additional gain in which there's just less DOM output overall. So instead of leaving an element behind on the screen for each item in the list, only the items that are rendered have DOM on the screen. And then there's a win on top of that in which the DOM on the screen is entirely recycled. So we just kind of a whole bunch of compounding factors added together. It's going to be a pretty nice win. I think the thing I'm most proud of it is something that I built rather recently, which is I call it a virtual component. It's actually not entirely virtual. And what I mean by that is it has 2 DOM elements, for lack of a better word. They're text nodes that it sticks into the document to use as placeholders. But unlike other things that have used this technique, which an example of it is Ember Wormhole, and also credit to whoever figured out in Ember Wormhole that you can use triple curlies to output a text node and it would be stable and you can use that to track location. It's probably Luke Amelia, but might have been somebody else in the Ember community, but I didn't realize you could do this. And then I was tasked with upgrading Ember Wormhole for Glimmer 2, saw that technique and went, I bet you I know what I could do with that. So the answer is what you can do with this is you create a single text range that you're going to recycle. And that text range lives on that parent component. Then in your virtual components, you have that start text node and that end text node. So whenever you want to measure the bounding box of the component, because this is the hard problem. The hard problem is, how do you measure something in DOM if you don't have an element? Is everybody that uses smoke and mirrors eventually comes to me with the same request. I want to be able to control the wrapper item, the child item in the list, especially because maybe I'm implementing a table and I want to be able to select that table row. So this isn't a situation where you can just have another div. You have to have control over that wrapper element. And Smoke and Mirrors doesn't have a good story for this. I've allowed some people to add some bindings, the class names and stuff, but I really did that kind of begrudgingly because this is a problem. It leaks state. When your wrapper element is being used for lots of different content that's being recycled, you can't attach state to it, because if you do, once it's recycled, it's in the wrong state. So I really want to just remove the wrapper element entirely. If you remove the wrapper element entirely, you need a way to measure DOM. So I had two choices. Choice number one is find a way to render it off screen first so that I can measure it. And choice number two was enforce that your component has to have a single top level element so that I can find it and measure it. But I actually don't want to do that, because maybe you want to use some really cool optimization techniques for outputting grids of things. And maybe each one of your items is actually a whole row in that grid, but there is no wrapper element for it. I need to be able to measure that row, but you need to be able to not have that element. So what the text nodes give me is one at the start, one at the end. All your content goes in between. You create a text range in between. And text range is something that you can recycle. You can just set it to a new start and new end. So when I need to measure everything in the list, I set to the first thing I need to measure. And text range has a get bounding client rect on it, just like a node does. So I do it for the first one, the second one, the third one, the fourth one, just walk down the tree and do it. So I ended up with a situation where it's about as fast as calling get bounding client rect on an element is, marginally slower. But the win is that I don't have to set up any of the DOM, and I don't have to enforce any strict conventions on you. I don't need a wrapper component. And so all of these other things combine together to where that small loss of it being slightly slower doesn't matter. It's wiped out by all the other wins.
Right, and this the kind of key to this is that you have to be able to allow variable height elements inside of the rows, right?
Yes.
And so
I need to be able to measure what you inserted, because if I don't, if I can't, then you have to tell me up front what your height's going to be.
Right, and that was a thing long ago, right? In Smoke and Mirrors, you had to have a fixed height row.
There's an option to have a fixed height row, and it's mandatory that you provide a default height, but that default height becomes a minimal height.
Yeah,
you won't have to provide that at all in the future.
That's great. Yeah, it sounds very familiar to iOS, like the tables in iOS. So the cell reuse and everything is all very similar.
It is intentionally very similar. A lot of the same problems to be solved. I suspect I'm going to have a slightly nicer API for it, but because you're not boxed in, like anything you want to do with your HTML and CSS will probably be supported. So Igniter is part of Smoke and Mirrors in the sense that for Smoke and Mirrors to do what it needs to do, you have to receive your adders onto your component, diff against what you currently have, figure out what's changed, figure out what belongs on screen. Then you have to figure out how to get from what belongs on screen and what is on screen into the optimal reshuffling of those items, and finally render it. Now, in order to do this, you're going to have to manipulate DOM, you're going to have to measure DOM, and you're potentially going to need to do that twice. If you don't have very tight control over when the render happens and when the paint happens, then you run a very high risk of you render some state and then you paint. The user sees an incomplete state, and then you go and you fix the state. And what happens when that happens is that you see a flicker. So if you're ever in an infinite scroll solution, and it seems like the content jumped a little bit, or if it seems like maybe that like the scroll height seems to bounce around a little bit or whatnot. That's what's happening is instead of being able to do it in a single paint process, it took them several paints. So I really want to be able to do this in a single paint. To do that, you have to have an organized way of controlling this flow.
And you thought that was going to be RAF, but
so I thought that I was going to I thought I was going to get a cheap win that would carry me over for a while by doing Ember Run RAF. But it turns out that I just didn't understand Backburner well enough at that point, because what Ember Run RAF did it reached into Backburner and it replaced the set timeout call with a request animation frame call. And if everything in Backburner were flushed via what's called an auto run, which is what ran through that set timeout, I would have been okay. But what I didn't understand is there are multiple ways of synchronously flushing Backburner. And this is very intentional because Backburner wasn't designed for really async queues as much as it was designed specifically to polyfill microtasks in an era in which there weren't any real polyfills available. Like, you can't polyfill a microtask in IE7, IE8, not even really in IE9. So Backburner is doing something that was way ahead of its time in terms of the spec, much less needed now. But I didn't understand that it wasn't just a set timeout. It was these microtasks. And so I kept still seeing flickers because things would be in the wrong order. And it was because, yeah, sure, I scheduled something into a RAF flush. RAF never even happened because everything was being flushed synchronously. So that was really trolling me. I didn't like it. It helped people's perf overall, but it also hurt people's perf in a couple situations really badly. Like, it was a win up until it wasn't. And the moment it wasn't, it went really bad. So we needed a solution that was going to be a universal win. So I started down that path of finding one that was a universal win. But where Igniter fits into the picture, specifically when it comes to smoke and mirrors, is I could have built a series of custom queues that, in fact, I actually did this in 0.6 in smoke and mirrors. There's a mini Igniter in it, but it's built in a way that I will replace. But side story. I could have gone down the road of just implementing this for smoke and mirrors and being done with it. Meaning, I have a queue, it's based on RAF, it ensures that a render flush happens at the right point before I do the measure, before I do any alterations, and the world is happy. Problem with that is, I'm not the only person in the ecosystem. Anybody else that needs RAF is going to interfere with my RAF. Anybody else that needs the measure is going to interfere with what I'm measuring. Which means that if I do this, I run a really high risk of forcing layout on people at a really bad time. And they run a really high risk of forcing layout on me at a bad time. And your performance goes from, oh, great, I can drop in smoke and mirrors and like everything's good, to like, this guy lied to me. There's no way this ever worked. Like, my perf is the worst thing I've ever seen.
Looks good on paper, but
yeah, like so I don't want that. So really, we have to, much like the cancellation tokens, enable everything asynchronous to play nice together. Igniter is an attempt to make everything that needs to be based on RAF, or really based on timers, whether it's a weak timing guarantee or a strong timing guarantee, play nice together. Things that frameworks need to solve.
That whole problem sounds very familiar. Have you ever heard of, I don't know if they call it tearing in GPUs, where where the monitor is rendering right in the middle, like the GPU starts rendering with it, and the monitor paints, and you get like a cut if you have anything moving really fast. And so the new graphics cards have these, like NVIDIA has some proprietary technology, AMD does, and the new monitors will have like this enable, it's like not VSync, but it's something like that in AMD, and NVIDIA has the same thing. And all it's doing is this. It's just making sure that the graphics card renders an entire frame before the monitor paints. It's the same problem. It's interesting.
I have discovered this the more I've worked at lower levels of the Ember ecosystem, that all problems exist in all ecosystems, and we're just often implementing the same good solutions that are found elsewhere. Cancellation tokens came out of C#. They are not a JavaScript originated idea. A lot of like the Glimmer architecture, a lot of what I'm doing with smoke and mirrors, these are things that came out of game engines. These are optimizations that have been well understood for decades, but it's just taken time to put them into JavaScript applications. I'll dangle a carrot. Carrots are nice, right? Okay, so what's next for Ember Data? I'm not going to hard promise anything here, but I'll tell you what we're thinking about.
He's setting up the next interview.
I know.
Right? Next time
Next
on
time.
Ember Data.
Next time. All right. What's next? I think most of core is really excited about immutability. I think all of us have an appreciation of what Redux has shown is possible. I don't think any of us like Redux. I'm gonna put that out there, but I can take you down the troll bandwagon of why it's not good. But I can also take you down the happy, joyous, car ride of why it is good. And I think we would all like to see an immutability story baked into Ember Data. So I think that's something that I'm not going to promise, but it's on the radar. I think something that's even more on the radar is getting Ember Data to work kind of offline first in a web worker, in a service worker, being able to roll it up, separate it out from Ember itself, and just kind of put it off on its own. I think that's pretty high up there. More importantly, kind of more near term, improving some of the ergonomics a little bit, but especially improving the story for fast boot and WebSockets. So streaming data applications or any sort of like stream into the shoebox, pull out of the shoebox kind of deal. I think that's really going to be a big focus more near term.
Yeah, I think that'd be really interesting to see some I don't know, like ergonomics around the shoebox. I feel like right now that's an area that's caused me to write some pretty gnarly code to work around some weird edge cases. So it'd be really cool to see that. I'm super excited about that. That's awesome.
And all the live data, like WebSockets, things like that. I constantly get people asking me about that and how do I deal with this? And it's something you always end up doing custom.
The RFC that people should look at and comment on and give feedback on for Ember Data, it's in the Ember.js RFC's repo. I think there's an outstanding issue to merge the various Ember RFC repos because Ember CLI has its own. I think Fastboot was considering getting its own. Ember has one. So this is in the Ember.js RFC's repo. It's RFC number 160 for JSON API document references and RFC 161 for basically push document. I think this is something that would really help people out with WebSockets, Fastboots. We could really use some feedback on it. I think we have a few concerns with the API still. They're probably going to evolve a little bit. Those RFCs, I wouldn't consider them really like ready to ship, but I definitely would suggest that people start reading them, commenting on them.
Definitely. So check that one out, and we'll make sure to post links to all of this stuff that we've been talking about as well.
Yeah. So many links.
So many links. Yeah. This is gonna be like 3 scrolls on Ember Weekend.
Yeah, first time. I might have to use smoke and mirrors.
Yeah.
So that it's not eating up so many resources. All right. Well, so that's all the time we have for now with Chris. But we're going to be releasing this episode in 2 parts. So by now you've heard both parts.
Yeah. Well, no, I mean we're going to put this ending at the end of both of them. So you really need to talk to 2 different audiences.
All right.
Yeah. Like
so.
Spoilers.
No spoilers.
Westworld spoiler view.
Stay tuned next week for the conclusion of this episode with Chris.
And I guess also the conclusion of this episode with Chris. Anyways, thanks, Chris, for coming out. I really appreciate you taking the time. Actually, we're co-located. We didn't mention at the onset of the episode, but we're co-located right now. So he actually is visiting our Jacksonville Beach area, which is super cool. And I think we're going to go get a drink after this. So
if you're in Jacksonville Beach and hearing this from the future, come back in time and meet us at the bar.
Meet us at the bar. Well, anyways,
you're already late.
You're already late. So we're Ember Weekend. You can follow us at emberweekend.com or on Twitter at Ember Weekend, all one word. And we have a feed at feed.xml, which isn't in iTunes. It's a whole long story. But once again, Chris, thank you so much for being a part of the show. And as you know, again, it's been great to have you for the second time. Hopefully, we'll do this in the future again.
Sounds good.
See everyone next week. What do we say?
Well, no. So we used to say, "See you next weekend." The problem is we never see them next weekend. They never see us. So I've been saying, "We'll talk at you next week."
That's terrible.
Without you being here. Terrible.
And we'll see you next weekend. I'm gonna keep all of that.
Well, thanks for having me. But I think this is just going to become a yearly ritual. So maybe see me next year.
Yeah, that's a pretty good one. Yeah. All right.
You saw me last year. I had just run a marathon in Death Valley.
Yeah.
You're seeing me this year, and I just ran that same marathon in Death Valley again. So
nice. Yeah. Well, we'll see you. We'll see you next year then.
Right after.
Hopefully, you'll make it through the marathon again.
I will make it through the marathon again next year. So you will see me next year.